Hi guys, Mr. Leonard here to discuss your acid rain reading questions. First, there are two types of acid deposition that exist. There's wet deposition, which can consist of things that fall from the sky, rain, snow, sleet, hail, fog, things like this. Even though fog isn't typically falling from the sky and is more on the ground level, it can contain some of these components that would make it acidic, having a pH of less than 7. We can also have dry deposition, things like dust and gases. These are things that are released from power plants, exhaust from cars, and both of these types of deposition, whether wet or dry, can be inhaled by people and cause health problems. So it does have a pretty big impact on some people. Now, acidity is generally measured on the pH scale, ranging from 0 to 14, with 7 being in the middle. Anything that's less than 7 is considered acidic. Some common items that you may know: lemons, tomatoes, apples, bananas, vinegar. All of these things are acidic. Anything that's higher than 7, so 7.1 to 14, is considered basic. Things like soap and ammonia, drain cleaner, baking soda, these are typically used as cleaning agents. Now, if a substance is neither basic nor acidic, it is called neutral. And that's right here in the center. And a great example of a neutral item would be water, regular water that you would consider drinking. Now, acid rain is formed mostly through, or the largest contributor anyway, is through human activity, the burning of fossil fuels, things like coal, oil, natural gas. Additionally, we get some of these dry deposition particles like nitrous oxide, sulfur dioxide from the exhaust from cars. Now, the sulfur dioxide is mostly coming from power plants. That's really important to note. Now, as these dry deposition particles go into our sky further up, they're typically traveling with water vapor, and when that water vapor cools, expands, condenses, well, it takes those things with it, and eventually it forms these clouds. We get enough buildup of clouds, we get wet deposition, or rain, snow, for example, coming down, and that can be acidic. So we can have things like acid rain, we can have things like acid snow, and these are typically found in our area in the Northeast. Now, the natural pH of rain is 5. Now we said, alright, well, regular water is 7, but rainwater has a pH of 5. The reason for this is because there's carbon dioxide, what we exhale, in our atmosphere, and that creates this substance called carbonic acid, and that is, of course, acidic, and that drops the pH just slightly. Now, nature has some great ways to fight acid rain. Some of the best things that exist are around us, everywhere that we can see. Our lakes, our streams, our soil, even our air. But if too much of these things are washed away by rain in acid rain or broken down faster, there's not going to be much of a way for Earth to combat this acid rain that has really been created by human activity. We could think of a common substance on the beach like a shell. A shell is made of calcium carbonate, which is a great natural defender to acid rain. So when the acid rain, or if acid rain were to hit a shell, it would neutralize it. It would break it down and bring it more to that pH of a 7, which would be great. Now people can be affected by acid rain as well, or acid precipitation. In some people, it can create heart attacks, respiratory diseases, asthma, and these are all things that negatively impact us. So our pollution that we are creating, our sulfur dioxides, our nitrous oxides going up into our clouds, and then eventually coming down as rain, as we see here, that can negatively affect us. And as we see this woman in this picture just covering her mouth. So it's something that's really, really important that we think about how we can change for the future. Not only does it affect us, but it affects our forest, our plants. You can see this picture here to the right. We have all these dead trees here. Well, acid rain starts to break down nutrients, real important ones like calcium in our soil. And what that does is it blocks certain nutrients from being absorbed and also creates this aluminum barrier, so to speak. So it prevents, it creates that block. It makes it hard for the plants to get the things that they need to survive. So this is a huge, huge negative impact. Now, if we just take a look here, we're looking at an image of a forest before 1880, before the Industrial Revolution, and then 100 years later, 1980. We can see the pH levels of our rain have changed from 5.6 to 4. The pH level inside our soil has changed from 6 to 4.6. So this has had a huge impact. And if we were to take a closer look at the leaves, they would start to look something like this. Alright, now we know that the surface of a leaf, especially from what you know from middle school, is really, really important because that leaf surface is vital for photosynthesis. That provides the energy for that particular plant to survive. So if the surface is broken down, it's going to be harder for that plant to survive, and ultimately can start to look like this in conjunction or working with, or having those nutrients being blocked as instead of being absorbed. Acid rain can also affect our lakes and streams. Now they're a natural defender, but think about what's in there. It's not just water. We have aquatic life. Take a look at these poor fish. These fish have been killed from acid rain. If enough acid rain gets in a body of water, it changes the pH. Animals typically don't like pH levels under 5, and if it hits those levels, they typically die off. So we could be talking about huge bodies of water potentially eliminating much of the life that's in there. And of course, we have our buildings and monuments. Things like statues and gravestones. Well, things like marble, limestone, they typically break down much faster than other materials. Here's a great example. Here we have a tombstone, and you may recognize this picture from before our lab. Here's a tombstone from 1922. Here's a tombstone from 1892. This one is much older, but easier to read. The reason for it is that this is probably made of something like a granite, which is more resistant to that acid rain than something like this, which may have been marble, and it breaks down really easily with acid rain. Now, Congress has done something in the early 1990s, in 1990 in fact, before you were born, called the Clean Air Act. And what that does is it puts a block on how much pollution, how much sulfur dioxide and nitrous oxide that power plants can release. So that was a great first step. Additionally, scientists have suggested washing coal or using a coal that burns more efficient, like anthracite, and also to install equipment that removes or filters out some of that sulfur dioxide. Again, we've seen that word a lot before it actually leaves the smokestacks. one of the best things that could be done for us nowadays is to use more renewable energy resources. Things like solar or wind or hydroelectric. All right, solar's free. The wind is free. Hydroelectric is free. These are all things that are provided by nature. If we can harness the energy from them, we can use less non-renewable energy resources like coal, oil, and natural gas, because once those things are used up, we can't get them back. Thanks for listening, and hope you had a great chance to correct your homework. And if you have any questions, just go back and replay any part of the video.